Speaking about Hydra, we have some exciting developments along those lines to share. And Hydra is part of an initiative called multi-render inside of Octane. And multi-render is meant to allow you to swap any other render engine besides Octane on the fly in a matter of seconds. It's as easy as switching between rendering kernels currently in Octane. And we're using this technique to bring our own renderers and other renderers into all of our Octane plugins. So the first ones that we want to support, of course, are Brigade, which is our real-time renderer, which we'll be showing as well, and an anime renderer, which is an NPR renderer that we've been developing for a while, and now is its own Hydra render delegate. And for third parties, we want to support Arnold, which is, of course, our partner on the render network, but ultimately just support any Hydra render delegate that's out there. And that work seems like it's very tractable. So we'll be showing some of those results in a little bit. First up, our anime engine, which we've been developing as a possible render kernel, we decided to break that out into its own renderer, now is running as a plugin in Octane. And you see it's running not just in Octane standalone, but it's running in Houdini Solaris as a render delegate. The anime renderer is actually pretty cool. It has line rendering and edge rendering. It's completely optimized for RTX hardware, so it runs basically in real time at 4K 30 or HD 60. And we see it having a lot of potential for cell and image rendering, which traditionally hasn't necessarily been done on the GPU. And it looks beautiful, and it runs super, super fast. And using multi-render, we don't really need to bake it into Octane. It can just run as a render delegate, a Hydra render delegate, and then you load it into Octane Core and all the Octane plugins this way. And it's simplified a lot of development. It also means we can parallelize work a lot more than we used to by having multiple render engines being developed in tandem and then sort of bridging those together. So next, I want to show how Arnold works with the multi-render system. And this is really cool. So this is Octane standalone, rendering Arnold live. And this is me switching between Octane and Arnold. This is Octane. 1 second, it's now Arnold. That's pretty amazing. So that's how fast it takes to switch between two different renderers. I'll show you. Here's another example from the Octane 1 splash screen documentation. This is an Octane. I'm switching to Arnold, and in about a split second, it's rendering in Arnold. That's pretty great. And you can use the Arnold film buffer with all of the Octane post-processing effects, and you can even control the Arnold viewport directly, as you would the Octane one. So it's basically like a render kernel, but it's using a completely third-party rendering path. And with that, you can also do many other effects that have been tricky to do in the past. For example, you can render both Arnold and Octane at the very same time. This is all within Octane standalone, and combine those viewports and mix those with post effects. So that compositor tool that I had shown before, well, you can now take that and let me go back a slide here, and you can use that to take certain elements from Arnold or Octane or even another renderer and composite those together. So the volumes from one renderer and the scenes from another can actually be composited live at render time. And we support both Arnold CPU and GPU in this framework, and you can see material conversions already pretty far along, and more is to come. So we've also, along the with Arnold, supported Pixar's Storm Render, which is a preview renderer, and Intel Embry, which you can see on the left. And those just basically come with the Hydra SDK. But there's a lot more out there. So we're also, of course, going to be bringing this system to all of these plugins. So if you want to use Arnold inside of Unreal, it's going to be possible to do that. Every single one of our GTC plugins will now become a system capable of supporting Hydra render delegates. And in the world of rendering, there's a lot of renderers that are being adapted. So one of the ones that's already nearly working is Cycles. So you'll be able to just use Cycles inside of any of our existing plugins. Of course, Arnold. The Omniverse renderer, which looks fantastic, is built on Hydra, and we're talking to NVIDIA about bringing that into render. And there's many more out there, many more open source ones that we could probably just build and ship for free with Octane, and that includes Google Filament, Lux Render, Intel Osprey. They're all open source like Cycles, and they all can be, when they're further enough along, shipped as free renders that go alongside Octane and Brigade. So the two cases that are really interesting and kind of doable with the system are Unreal and Blender. Now we have the full source code to both of these tools. UDK and Blender both are buildable by us. In fact, we ship a custom version of Blender just to support Octane. And we can compile these into special modules that expose their built-in renders as render delegates. So that means Eevee and even Unreal Engine could be added to multi-render. And you could just switch to Unreal Engine or Eevee with the system. And that's pretty mind-blowing. But all of this work we've done for a specific purpose, which is we wanted to get our own real-time renderer Brigade into all of the Octane plugins. And everything else, frankly, is nice, but Brigade is really the core focus of why multi-render exists, because Brigade is the future of where we see GPU rendering going. Octane will always have a place. The quality of spectral rendering is absolutely fantastic, but we've always wanted to see real-time have come to fruition. And with RTX hardware now, and the majority of our users now have a Turing or later card, and especially with Ampere, we're seeing real-time becoming much more viable. When we first started talking about Brigade and showing demos, it was running on the equivalent of 80 K80. This is about 3,200 Octane bench is what this was showing. And that's what it would take to get Brigade running in real time, 720p 30 as the example here. But it really was just a question of scaling. And with RTX hardware, the scenes that are leveraging Brigade, Brigade's written from the ground up to leverage RTX. It's written in Render. It's not using CUDA or optics. And in Vulkan, we're seeing pretty great performance. Info channels, for example, which we got working in 2019, or even direct lighting, it's super simple to get that running at 4K in 60 or 30 frames a second. And that's what RTX hardware delivers. And so Brigade, if you're just trying to replicate what Octane's doing in direct lighting or info channels, right out of the box, you get noise-free results, and it just works great. But direct lighting and info passes and AO are not path tracing. And obviously Octane, when you're creating final renders, it's using path tracing. So this year, we started to show the first results of Brigade's path tracing kernel. And to be frank, I think it's pretty awesome. This is Octane on the left, Brigade on the right, 4 samples per pixel. Brigade is just able to render it faster and get there quicker. Now, there is always going to be a difference. I mean, Brigade quality is really, really, really good. I mean, it is full path tracing, no shortcuts, but it's not spectral. It's an RGB renderer. The material system is not as advanced as Octane's, but nevertheless, you have scenes like this one, ArchViz scenes, Octane on the left, and you have Brigade on the right, and they don't look that different, except the one on the right is rendering at 60 frames a second with path tracing. It's pretty incredible. So designing Brigade from scratch around RTX, I think, has been a good bet. And while we weren't sure that path tracing would actually work at this speed, we're now reasonably certain that we're going to make that happen and get that into users' hands. So we've also gotten really good volume rendering support inside of Brigade. You have instant environment volumes, so you have God rays for free, basically. The medium node in the Octane environment is replicated in Brigade, but it is essentially real time and very fast and very little noise. So if you take Sculptron lights, for example, like we're showing here, those inside of Brigade are awesome. I mean, you actually can get caustics out of Sculptron lights, which is pretty amazing. Refractions, which we didn't show 6 months ago, we're working really well on Brigade. This is showing IOR refractions in real time. Looks beautiful. Again, basically free and in real time. And we also have been able to master really complex things like path traced volume caustics, which we're seeing here. That basically doesn't even render anywhere near real time in Octane, and here we have that running in Brigade. It only works with Sculptron lights, but still super useful. And we've also been working on very fast depth of field effects. That's still sort of a work in progress, but it's running really nicely even on a 2080, which you're seeing here. Now, there's other types of caustics as well, refractive caustics, which are really tricky. You saw that working there. It's just an early work in progress. Subsurface scattering is also in progress. Chromatic lens effects, we actually have those already running in Brigade. They're running pretty much in real time. And what I'm going to show next is probably the hardest and worst case scenario in Brigade, which is mesh lights, mini mesh lights in an interior scene. This is running not always at 60. I mean, it drops down to about 10 frames a second. And there is a little bit of noise and splotchiness, but it's working. And it's still pretty early. But this shows that yeah, you'll be able to render pretty much anything with Brigade, and it'll still be real time. So next, I want to show what real production scenes look like in Brigade, because that obviously is better than just demos. And some of these I posted on Twitter and social media, but this is more of a deep dive in them. So we're going to take scenes that we've rendered for a while in Octane, and they're exemplary, and show them in Brigade and see what the difference is. So this is one example of a scene, and you can see on the left Octane rendering, which is actually pretty fast, and Brigade on the right. But Brigade is rendering it at 60 frames a second. There's probably greater scattering depth in the Octane one on the left, but this is a scene where the spectral rendering, yeah, you don't really miss it so much. I will say that having used both of these renderers now, it's a little bit harder to get the quality that I want right out of the box in Brigade, but I think with time you can really get that to work. And that's something that, again, is probably limited by the fact that Brigade is still pretty early, but it looks awesome. The daylight system from Octane is fully replicated in Brigade. Again, it's real time. Things like turbidity and, again, volume caustics, really trivial to do. Next scene is a famous scene that's done by Rick the Asian from the Octane 3 splash screen. This was something that actually did render faster with RTX, even in Octane, but nowhere near real time. So on the left here, I'm showing the Octane version. On the right, Brigade, on the same GPU, and the difference is absolutely stunning. Again, in this particular scene, the quality is pretty close in terms of, if you actually look at the final renders, they're pretty similar. But Brigade is just going through this thing so much faster. And the reason for that is that, again, it's a simpler render. So the material system is a bit simpler, and this scene doesn't necessarily push that. If you were to do layered materials, for example, that wouldn't work in Brigade. And there are many things that are that are still missing. Like we don't have volumes, we don't have hair, we don't have motion blur just yet. But for things that do fit within the features that are currently in Brigade, the results are just incredible. Here is another example showing the daylight system close up, and you also have caustics and other things as well that are in this environment. And it's amazing. I mean, it is a world of difference to be able to take a scene that is close to production ready right out of the box and keep editing it and using it at 60 frames a second. And so Brigade is truly, again, seeing the progress we've made in the last 6 months feels awesome. Now, a lot of questions we get is, when is this coming out? The answer to that is sometime next year. We may have a demo or a benchmark or something the end of this year, because clearly it's fun to play with even in the current state. But we do want to get it to a point where it's built into multi-render and it just works with most scenes out of the box before we make it something that artists get to really play with. Here's another scene. I think this one's even bigger than the last one. This was the Octane 2 demo scene that uses tons of instancing. And the scene is actually using a truck from Evermotion. Again, Octane on the left, Brigade on the right. Pretty close in quality. I would say almost the same in a lot of respects. And you have the Brigade one on the right here. The one on the left in Octane, which is basically on the same GPU, actually struggles to capture the video. It's just pretty noisy. The difference between the two is just pretty crazy. And here's the Brigade one again, 60 frames a second, full path tracing, just works. Actually, let me back. This example is me testing it on a 4K display. This is on a Quadra A6000. 3090 is about the same speed, but this is 4K. 4K rendering this scene. It's on one GPU, and that was rendering, by the way, at 60 frames a second. If you go back to the slide here, you can see it's rendering this frame at 19 milliseconds. Absolutely stunning. So, how does Embergen and Brigade work together? We've already done some tests with that. We actually want to support VDB volumes. So you can see here there's volume rendering working inside of Brigade. It slows the frame rate down to about 30 frames a second on a 2080, but it's 60 on a 3090. And you can also see here, this is just one snapshot of the Embergen simulation, but it works. The volumes cast shadows, and scattering, single scattering at least works in volumes. So it's pretty cool. And being able to get volumes this early into the Brigade engine is great. And of course, with Embergen simulating stuff in real time while you're rendering in real time, amazing things are possible here. I showed this previously. Brigade has a light caching system. It can take essentially the output of irradiance, which we're developing for the ppm kernel in Octane, and it can use that to skip the GI step inside the rendering. Now, that's kind of useful for games, but as you've seen with these other videos, Brigade's fast enough to do full path tracing without any sort of tricks. But this is something that we think is actually pretty useful for non-RTX cards, and in particular, iOS devices with ARKit. We are building Octane and Brigade for iOS, so in this case, having the irradiance cache is going to be super useful. As far as render modules go, there's more than just render plugins, right? We have Embergen, we have World Creator. The module system itself is divided into sort of 3 parts. You have physics tools, and you also have procedural tools as well. But for physics, we're adding our own soft body and rigid body physics system. It's based on PhysX and Bullet. You can have 2 backends, so it'll allow you to drop in different physics engines. This is actually an early Brigade test running Bullet while it was doing path tracing. So we just want that to be built into the render stack. And I think it's fairly similar to the work being done by Omniverse with NVIDIA dropping PhysX inside of their system. So we see all these efforts as complementary. This is a product called Storm running with Octane, and it's used for grain simulation. It looks awesome. And we're working with the developer to port Storm to CUDA and to get it to work on the GPU. And we're probably at that point going to look at offering it as another render module along with the rest. Sculptron, our GPU sculpting tool. It's really powerful, and it's been available since last year, but we've made another release this year that has a lot of new features. There's a timeline, a whole new UI workflow as well, and that was this alpha was released in July. It is a lot faster than the previous version by a factor of 10. And again, entire system is based on the GPU. So you have a GPU sculpting tool. All the tools that we want to introduce alongside Octane are typically taking problems that were CPU workflow problems and getting them adapted to the GPU for huge increases in speed. So for the future, we want to have full USD support in Sculptron. We're building a mesh modifier stack that allow you to do all sorts of operations in a node-based system. And we're also going to be adapting Sculptron for the iPad and for tablets. And we want to support authoring forces, fields, and physics-based operations. The list of things we're adding to Sculptron over the next year or two is pretty huge. But it'll be a really nice, simple DCC tool at the end of the day with a focus, of course, on sculpting and temporal sculpting in particular. Next, I want to talk about Octane X, which was a release that we put out this year on Metal. After 10 years, we ported Octane from CUDA to Metal. And one of the things that's amazing with this work is that we actually have all of Octane completely running on the iPhone. This is my iPhone 11 running PMC kernel, and you can just take any Octane scene and it just renders without any difference to the CUDA version on an iPhone device. And it's pretty fast. I mean, it's 15 Octane bench. It's about the same speed as an Intel MacBook GPU, 2020 13-inch MacBook Pro, right? That's crazy. So if you actually were to take your iPhone and add it with network rendering to your MacBook, you'd have double the speed. But it's really fast for interactive rendering. And why this matters is that we want to get everything running on the iPhone because we want to have this for AR and other things. But you could do full production rendering on your phone. You can actually, in this case here, we're starting a scene, and the final renders just look absolutely beautiful. It's pretty incredible. So you can kick off, of course, renders that are started on a phone to render. That's kind of the point. So probably Octane X on iPhones will remain free, and you'll just basically will subsidize that through render jobs. And as I was saying before, you can actually use network rendering with the iPhone to double the speed if you're rendering on a MacBook, or even provide GPU rendering at 15 Octane bench to a device that doesn't have any of that. Now, with Brigade and Octane X on the iPhone, and having the full stack there, we see a lot of potential in AR. So going back to what we were showing before with the irradiance cache, here's another example I've seen from Keloid that's running on an iPad. The irradiance is cached, but it's running pretty much in real time in AR on that phone, and it's only doing reflections. GI is essentially baked in. We don't have to bake it in. We can, we can calculate it in real time. and it's pretty fast. But again, I mean, we're not talking about thousands of Octane bench here. We're talking 15 Octane bench. So we want to come up with ways that address AR in real time in clever ways. Here's just one character from that scene. Some of the tools that we're developing for Octane on iOS include really good tracking. That's improved a lot with the LiDAR tracking, but we can also do marker-based tracking. And an important consideration here for making AR truly work is being able to do lighting. Being able to sample the scene is something ARKit kind of does for you, but we built a custom solution, and that allows us to do really complex things like you're seeing here, where we could do live ray trace reflections on objects and scenes, and that looks pretty great. So if we can feed that into the ray tracer, you can really do on-set compositing and rendering with this system. Now, some of these assets that are coming in from Octane can have pre-computed radiance, but a lot of cases, things are dynamic. So, we don't have that, or we have to do it in a little more, clever way. So I want to show dynamic scenes next. And here's an example from Keloid. That very same robot is actually dynamic in this example here. This is something that was maybe a year old. The newer version is actually really nice. So this is a more recent version of the renderer, and it's pretty close to the production version that we have on the desktop, while still staying in real time. And we subsequently added support for things like motion blur inside of AR, which is great. So the idea with this is that you've had viral videos that are done with, let's say, Octane for C4D, like the example on the right, taking an asset and spitting that out on Instagram, and it's really popular. It also is something that we think a lot of consumers using an iPhone would really enjoy. So being able to take all of that and do it all from a phone, like we're showing on the left, is, I think, a game changer. And we want to see more of these kinds of effects done with Octane for iPhone, but it also allows you to do really cool AR effects. But I think just from the perspective of what you can do offline, like these videos are insanely cool, and they're all done in Octane, but they're done on the desktop. So when you're talking about production scenes going into a system like this, like here's an example of an Urbach file done by BLR, and on the right is that same dynamic scene with destruction and everything running on the iPhone in Brigade mode with hybrid rendering, and it looks pretty good. It looks pretty good. So again, dynamic scenes with Octane or Brigade rendering them live is viable. I mean, I think the best for real time is basically Brigade with the irradiance cache, or no irradiance at all, like we're seeing here, and you still get great effects. So